I didn't used to teach this till I saw them testing it on the AP test. So we'll say the following, well, let's do the curve first. Don't copy anything till I'm happy with my curve, okay? Because I might screw up. So don't copy the curve until I'm happy with it. Because I might have to fix something if I screw up, which I might because it's drawing. And on the AP test, this would be a lot better drawn to scale than it is when I did this. And they would tell you it's a weak acid, but I didn't write that in there. So the above titration curve was generated when HA was titrated by KOH. Calculate the Ka of HA. So I'll give you a minute to see if you can take the information we just talked about. And I say calculate, but there's some estimation involved. Again, on the AP test, there wouldn't be much estimation because they would draw up the scale really, really well, where you wouldn't have to guess at numbers.
Wait, what is the opposite of log? Is that like LA?
10 to the negative.
Oh, okay.
So remember, pH is negative log of H plus, 10 to the negative pH is H plus.
What's it again?
So you agree that pH is negative log of H plus. So 10 to the negative pH is equal to H plus.
Okay.
So if Ka is negative log of Ka, 10 to the negative pKa, and I'm going to go over that.
Okay, so do you know your midpoint is? Okay. So is your pH level, right? So what's your pH level?
Yeah.
At your midpoint.
I think it's good if I can sit
Hey. Okay,
Oh.
She goes PK.
Five. Okay.
Why do they do it so low?
Five. I heard that.
Nicholas, not 10 to the 4. Is it 10 to the power of negative number or 10 to the power?
No, we're looking at this. We're looking at
Oh, wrong.
Look.
Which is yours?
Good job.
What did I put in wrong?
I'm going to go over
Put in the calculator. Like, how do you do it like this? Like,
Oh, yeah. You do second.
but let me see. Sorry.
You know what it clicks? It's second log and then second negative.
Yeah.
Wait, where'd you get?
Go over it, or do you want to keep thinking about it? All right, let me go over it. So Can somebody give me a guess, what's the volume added at the equivalence point? Equivalence point's around here, so it's about 40 milliliters at the equivalence point. So equivalence point, 40 milliliters. Midpoint is going to be halfway to the equivalence, so what's the volume at the midpoint? So then our estimated pH at 20 milliliters is around. Is everybody good with how I'm getting that? Are you good with it? Do you understand?
Wait, how did you do pH again?
So I estimated the midpoint's 20 milliliters, and that's around pH 5. And now we know at the midpoint pH equals pKa. Therefore, pKa must also be 5. And then, earlier this year, we know that pH is equal to negative log of H plus, and 10 to the negative pH is equal to H plus. So if pKa is negative log of Ka, then 10 to the negative Ka, 10 to the negative pKa is going to equal Ka. Right, so it's that same equation. We'll need to use this equation. And then 10 to the negative 5 is 1 times 10 to the negative 5th, which is my Ka. And that's my answer. That's why I stress the midpoint. You have to know pH equal to pKa, because they love questions like this. Not very hard as long as you know the material you need to know. Any questions on it? Almost done. I've just got to talk about the flip of this. With weak base in the flask.
So is it just what about weak acid? Is that a thing? Like
We don't generally do that. We always use a strong in the burette. We never do a weak acid and a strong base. I mean, theoretically we could, but I've never seen it. Or seen it on the AP test or in a college textbook even. It's just a lot more complicated.
Did you finish your online math? Well, it says here. The one doing yesterday?
Yeah.
Did you end up reading the journal?
All right, I'm going to talk about the last type of titration, and then we are finished acid base and only 4 more days of teaching this year.
Dang, Miss Thatcher. So you get paid for free.
Plus all the review sessions I'm doing.
Well, you still got to teach advanced.
Well, yeah. But my caring becomes, I start surrendering to I don't care a lot after May. And the teaching in advanced is a lot easier than the teaching in AP. All right, so now the last type is weak base in the flask, strong acid in the burette. And here I want to clarify something I really don't like the way she taught it in the video.
I didn't like her.
So,
Wait, I have a question.
yes.
So for the first example question, how do we know which one was if the weak base in the flask or the burette? Like for that example, like
It starts acidic.
Okay.
If it starts pH below 7, then it's got to be the acid in the flask.
Okay.
Does that make sense? And that's what I'm talking about now. When the base is in the flask, the pH is going to start high or low. So it's going to be kind of flipped from what we saw before. Again, it's going to be, and I suck at drawing these.
You said this last one, right?
So something more like this. Now, important, if it's a weak base, so I'll do an example. If we do NH3 plus OH minus, or sorry, I guess I got to do an acid, plus HCl, we're going to get NH4 plus Cl negative. So I want to talk about what the pH at the equivalence point is going to be. We do What's pH at equivalence point going to be? Not 7. When these are wiped out, this is an example, weak base, strong acid. When these are wiped out, I have NH4 plus. That's what? Weak acid or weak base? Weak acid. Or the other way to think about it, the conjugate acid of a weak base is a weak acid. pH is going to be below 7 at the equivalence point. And that's very important for you to understand the differences in the pH at the equivalence point.
You said it again.
Hold up, let me finish writing it. Because, Madison, at the equivalence point, this product is a weak acid. So the pH is going to be below 7. This is again going to be the buffering zone, just like it was in the last type. Now, I don't like, when she talked about the midpoint of this type, she said POH equals PKB, which I think is just stupid, because this is still true. Here's the thing, when we have a conjugate pair, don't we always have a weak acid? So the pKa of the weak acid is still equal to the pH. If they wanted a Kb, could I get the Kb of A minus here?
Yeah.
I can just use that other equation. So just think about it this way. Get the Ka, and if they want a Kb, do that other equation, the 1 times 10 to the minus 14th, divided by K to get Kb. But this way, no matter the type of graph, pH equals pKa at the midpoint, and just do it that way. Don't mess with the POH thing, but if you want to do it as POH equals PKB, knock yourself out. Any questions? All right, that's